Okay, so in this next problem, again, we are going to assume that the compounding periods are different than years, and the payment periods are also different than the compounding periods. And in this case, we are going to say that the payment periods are smaller than the interest periods, which means during an interest period, there will be payments more than once. Okay. Now you see, let's just say you have a savings account and the interest is compounding on annual basis. Now, throughout a year, during a year, in the middle of the year, you are making many payments. Though none of these payments are going to gain any interest, because if you want the principal to gain any interest, the principal must stay in the account from the beginning of the interest period until it's end. You should not touch that money. I mean, during a interest period, if you just invest or deposit a money in the last day of the interest period, you are not just going to gain any interest for that. Though, even though you just deposit that money one day after the initialization of the interest period, still you will not be able to gain any interest from that. So the money should stay in the account from the beginning of the period until the end. Therefore, when the interest periods are larger than the payment periods, some of the payments during the interest period will not earn any interest in that interest period. Maybe in the next interest period, it may gain interest if you do not touch that. And for example, if in the beginning of the interest period, you have deposited a certain amount, but during the interest period, which is not complete yet, if you withdraw some of that money, then you will also lose the interest, possible interest that you could have gained from that withdrawal amount. But from the rest of the money that is left in the account, you can still gain interest. Okay, so if you make any withdrawals during the interest period, you will lose the potential interest that you are going to get in the end of the interest period. And even though you make a deposit during the interest period, you are not going to get any interest for that amount. Okay, so how this is going to work? Of course, there are some exceptional situations here, so I'm just going to explain that, and then I will read the rest of the presentation file. Let's just say you have started the interest period with $100,000. Then, after 1 month, so let's just say the interest period is for 1 year. After 1 month, you have also deposited an additional $10,000. Now, of course, you are not going to gain any interest for this $10,000, even if you have deposited this money in the earliest parts of the interest period. It does not matter. It is not deposited in the beginning of the period. So this $10,000, even though it is deposited just 1 month after the start of the interest period, you are not going to gain any interest for that. Now, after 1 month, let's just say in the end of February, you withdraw that $10,000 which is deposited earlier. Of course, in this situation, because you have not touched your initial principal amount, which was $100,000, you have just withdrawn the amount that you have deposited 1 month earlier. You will still get your interest from the initial principal. Okay, so if you have made any deposits during the interest period and withdraw the same amount, in that case, still you will get your interest for the initial principal. Okay, but if somehow the amount in the account is reduced below the initial principal, in that case, you will lose the interest that you would get from that loss amount. But the rest, which is not touched, will still help you to earn interest. All right. So then how we are going to solve these type of problems? We are just going to solve applying this small sized algorithm. It will say that for any period, we will start with the last cash flow in that period. Okay, so in any interest period, there will be different amounts of withdrawals and deposits. So there will be many different cash flows at different times during the interest period. So we will start with the last cash flow in that period. If this last cash flow is a positive cash flow, if it is a deposit into the account, remember we are studying this problem with respect to the account, okay, or point of view must be from the account's perspective. And if it is a positive cash flow, if it is a deposit in the account, in that case, we are going to move it right to the beginning of the next period. Because if the last cash flow is a positive cash flow, of course, it is not going to help you to earn any interest. So it is just going to be the same as if it is deposited in the beginning of the next period. Okay, so we will move it right to the beginning of the next period. But if it's a negative cash flow, if it is a withdrawal, we are just going to move it left to the time of the previous cash flow in the same period. So we are going to move it to the previous cash flow's time point. If it is negative, then we are going to calculate the net cash flow at this point. And this new cash flow is net cash flow is going to be the last cash flow in that period again. And we are going to repeat the above step for this last cash flow again until no intermediate cash flows remain within the period. Then all we need to do is we are going to, in the end, if we apply this algorithm, in the end, we will only have cash flows occurring in the beginning of each interest period. And then we are going to study the problem in the same way as we have studied the interest periods coinciding the payment periods. Now, of course, this algorithm can only be understood easily when we practice it in a real example. Now, in this question, it says that a person has $4,000 in a savings account at the beginning of a calendar year, and the bank pays interest at 6% per year, which compounds quarterly. The following table shows the transactions carried out during the calendar year as deposits and withdrawals. So the input of the question is given here. Right now in the account at the beginning of the year, there is $4,000. It is deposited and the nominal interest rate is 6%. Compounding occurs quarterly, therefore the effective interest rate per quarter is 1.5%. Okay. Now you see we have this table, and according to this table, many deposits and withdrawals are made into the account. For example, in the beginning of the year, $4,000 is deposited. It is also shown in this table. And on the 10th of January, a 175% withdrawal has happened. So which means in the first quarter, we are not going to be able to gain any interest for this $175 because it is gone now. Okay, even though you kept this money, $175 for 10 days, you will not be able to gain any interest over that. But for the remaining amount, you still have a chance to gain interest if you do not touch the remaining amount until the end of the first quarter, which is the end of March. Now, in February 20, an additional $1,200 is deposited. However, do not expect to gain any interest for that value as well, because I mean you need to keep a money from the beginning of the interest period until the end of it. So this $1,200 will not help you to earn any interest until the end of March. However, after March, in the beginning of the April, if you continue to keep this money for an additional 3 months until the end of June, in that case, you may get an interest in the next period. Okay. But in this period, there will be no interest paid for this $1,200. So the other withdrawals and deposits operations are made during these days. And as you see in the 29th of December, just 2 days before the completion of 1 year, $750 is withdrawn. And therefore, of course, this amount is not going to gain any interest or earn any interest. All right, so actually, in order to understand these transactions better, we definitely need to draw a cash flow diagram. Therefore, what we are going to start with is this. We are going to draw a cash flow diagram for this table, and that is just going to be this one. Okay, so from the savings accounts perspective, in that savings account, there's a positive cash flow in the beginning, which is $4,000. In 10th of January, there is a withdrawal of 175. In 20th of February, there is a $1,200 of deposit, so on and so forth. I mean, you can check the earliest table, the previous page table, and this cash flow diagram to see if everything is coinciding. Actually, everything is fine. And you see we have these cash flows in this cash flow diagram. Now we are just going to apply our algorithm. Why? Because you see the cash flow periods or the payment periods are smaller than the interest periods, right? Or in other words, interest periods are larger than the payment periods. Or interest periods are quarterly, and the payments periods are sometimes so small, sometimes large, but you see there are multiple transactions made in each interest period. So we are going to apply our algorithm. And we will start with the first period here. Now, in this first period, we are just going to focus on the last cash flow. And what is the last cash flow? There is a positive $1,200 of deposit, right? So this is a deposit. So what do? We need to move this last cash flow to the beginning of the next period. So we are going to take this $1,200 to the beginning of the second period. Now let's do that. We have done that. Now, in the rest of the first period, the last cash flow is negative $175. And remember, when it is negative, we move it left, not right. We move it left, but not to the beginning, to the previous cash flow. However, in this situation, the previous cash flow occurs in the beginning. So we take this 175 to the beginning of the period, but remember, actually, we need to take it to the previous cash flow. So when we take it to the previous cash flow, there will be a positive $4,000 and negative 175, and we need to calculate the net cash flow, and the net cash flow becomes $3,825. So in the next page, as you can see, we change it to the $3,825 of net cash flow, positive cash flow. Now you see there is not any cash flow left during the first period. In the we just have in the beginning and in the end, but we do not have any intermediate cash flows, either deposits or withdrawals. So we can move to the second period now. Now you see there are multiple cash flows in the second period, and it is just going to take several steps this time. So we always start with the last. We have $250 of negative cash flow. What do we do with it? We move it left to the previous cash flow. Remember, we are going to move this 250 withdrawal amount to the previous withdrawal cash flow, and the net cash flow at the previous time point will become minus $300. So we will just assume that this $250 is withdrawn at the previous time point. And after doing that, you will have a negative cash flow of $300 at the previous time point. Now, again, this is a negative cash flow, and this is the last cash flow right now. We are going to move it left to the previous cash flow again, and we will calculate the net cash flow. At that point, there's a positive 115 and there's a negative 300, and the net cash flow will become a negative 185. And The last cash flow right now is a negative 185. And we will move it left again because it's negative. We will move it left again to the point where we have a positive 65. And the net cash flow will become 65 minus 185, which will be a negative 120. Now, a negative 120 is the last cash flow. We will take it to the left to the previous cash flow, and the net cash flow at there is going to be minus 1,620, and the net cash flow is calculated here. And finally, during this period, the last cash flow is 1,620, and we will just move it to left again. And the net cash flow in the beginning of period 2 will become minus $420. So you see, we have completed the withdrawals, eliminating the withdrawals and cash deposits during the period 2. So there is not an intermediate cash flow during period 2 now. We can move to period 3. The last cash flow is $800. So what do? We need to move this last cash flow to the point of the previous cash flow, and we will calculate the net cash flow at this point. There's a positive 1,600 and there's a negative 800. So the net cash flow will be a positive 800 at this point, just like it here. Now, what do we do if the last cash flow is a positive cash flow? Remember, we move it right. The positive cash flows are moved to right to the beginning of the next period. And when this 800 is moved to the beginning of the next period, we will be completing the third period as well. Now we can study the fourth period. The last cash flow is $750 negative, so we move it left to the previous cash flow point and calculate the net cash flow there, and it is $1,550 at this point. Now, this is a positive cash flow, therefore we need to move it right to the beginning of the next period, which is just going to be end of the investment horizon. So we moved it. Finally, the last cash flow right now is the last intermediate cash flow, of course. We are not going to focus on this anymore because this is just assumed as in the beginning of the next period. So we are just focusing on the intermediate cash flows. And this $350 is negative, therefore it should be moved left to the previous cash flow, which is just the beginning of period 4 at this point. So the net cash flow in the beginning of period 4 will become 450. And this is just going to be the final structure of our cash flow diagram. Now all intermediate cash flows are gone. We just have cash flows, either a withdrawal form or deposit form, in the beginning of each period. Now the question is this: how much money will accumulate in this account in the end of period 4? So how are we going to handle this? Now you see in this each period, in this cash flow diagram, in each period, the effective interest rate was 1.5% according to the question. So 6% was the nominal interest rate. Therefore, the quarterly effective interest rate was 1.5%. However, we do not have a uniform series or gradient series here. So we have 4 cash flows, and we would like to calculate the end of the year balance in this account. So we will calculate the future value. So what we need to do is we need to handle each cash flow here one by one, and we will calculate the end of year value for each cash flow. So how are we going to do that? The future value in the end of period 4 will be the principal 3,825 times single payment compound amount factor under 1.5% for 4 periods, because this money is just going to stay in the account for 4 periods. Now for the second cash flow, there is a negative 420, and we will apply a 3 periods of compound amount factor. So we need to multiply minus 420 with f over t single payment compound amount factor under 1.5% interest for 3 periods. Now, in the end of the second period, there is a 0 cash flow. So we multiply it with the single payment compound amount factor for 2 periods this time, again with the same effective interest rate for each period. The last $450 in the beginning of period 4 will be subject to 1 period of compound amount factor, which is simply going to be multiplied with 1.015. And finally, the last cash flow in the end of period 4 is not going to be compounded at all. It is just going to be deposited at that time point, and it is just going to be contributing in the total balance. However, it will not gain any interest, of course. And the total amount will become $5,627. All right. So this was how we study the problems where the interest periods are larger than the payment periods. This was just a typical example. We are going to continue with the geometric series of cash flows in the next video.